Okay, this is the second part of day one. Kind of pretty much the same thing, just a little bit more, I guess, complex, a little bit more in-depth questions, but same idea as what we did yesterday. So let's get started. I can use the trig identities, all of these, to evaluate a trig expression, and I can solve trig equations. So this first one here, again, we want to get it down to a single function or a number if we can. We're going to get all the way down to a single number or function. So if you remember, here's a Pythagorean identity. If it has 1 minus cosine, think of this as subtract cosine over. So 1 minus cosine squared equals sine squared. And cosine over sine is cotangent, so this would be cotangent squared x. Up here, secant squared minus 1. Well, think here's secant squared. If I subtract the 1 over, that would be tangent. So tangent squared, x. I get kind of theta happy. I write theta for everything. I need to be careful. Over tangent x, and now this is tangent squared over tangent. So think of that as like x squared over x. Well, one of these would cancel one of those, so it's just going to be x. Well, this would just be tangent. So this would equal tangent x. And this one here, you see something like this, just kind of write them all. If they're reciprocal functions, write what the reciprocal is. Sine, cosine, like everything in terms of sine and cosine. That kind of makes it easier. So secant would be the same thing as 1 over cosine. Tangent is sine over cosine. And then cosine we'll leave alone. It's already in terms of itself. So now what can be canceled here? Well, cosine cancels with one of those cosines. So now I have sine x over cosine x, which just so happens to be tangent x. Okay, this guy here, think about when we did, this was in Algebra 2, you had these rational expressions, and you get common denominators. So right now, if you can't factor either of these denominators any further, so that means the least common denominator would be the product of these two. So if my least common denominator is a product of these two, then the only way to get that would be to multiply this first this first fraction by secant x tangent x, secant x plus tangent x on top and bottom, and then the second one by secant x minus tangent x on top and bottom. Well, if I multiply by 1, that's just going to be secant x tangent x times 1 minus, and this one over here would be secant x tangent x, I'm sorry, I wrote that wrong, plus, and this one would be a minus, secant x plus tangent x, and then secant x minus tangent x. Getting ahead of myself. But this minus here, I'm really going to distribute that out. So it would be minus secant minus negative tangent. So really that's going to become a plus if I just drop the parentheses now. So it's going to be minus plus. And this is all over the product of these two. When I multiply those two together, secant times secant is secant squared. The outer product and the inner product are opposites. They'll go away. And then this would be a negative tangent squared x on bottom. So looking at the top here, let's see, so the secant x's would cancel out. Secant x minus secant x. Tangent x plus tangent x would be 2 tangent x. Tangent x, not tax, tangent x. And then on bottom, if you look at this guy here, I've got secant minus tangent. So if I subtract the tangent over, secant squared minus tangent squared, I just get 1. So secant squared minus tangent squared is actually 1, so that's over 1. My answer is just 2 tangent x. Okay, same idea here, kind of take the same approach. The product of these denominators would be the least common denominator, so that means I got to take cosine x times this cosine x times that. So cosine x times 1 minus sine x, well that would just be, if I distribute the cosine x out, it would be cosine x minus cosine x sine x. Plus, and then on this one, if I distribute that out, cosine x times 1 plus sine x would be cosine x plus cosine x sine x all over. And now if I multiply these together, I get 1 minus sine squared x. Because again, the outer and the inner products would wipe each other out. So I've got a negative cosine x sine x and a positive cosine x sine x. So I've got cosine plus cosine, so that'd be 2 cosine x. And then 1 minus sine x would be the same thing as, 1 minus sine squared x equals cosine squared x. And, if you got a cosine on top and a cosine squared on bottom, one of these cosines will cancel out one of those. So I got 2 over cosine x, 2 over cosine x. And this cosine being on the bottom would come up, and that it would come up as a secant. So 2 secant x when it comes up. So that would be the simplest answer. Number 6, let's multiply that top out and see where we can go from there. So if I multiply that out, those are conjugates. So it would be secant squared x minus 1 over sine squared x. And secant squared minus 1, using your Pythagorean identity, that equals tangent squared over sine squared. And then from there, tangent squared, I could write that as sine squared x over cosine squared x, all of this over sine squared x. So if I want to simplify this, think of this as over 1, sine squared x over cosine squared x, and then flip this over times 1 over sine squared x. So that would equal, these would cancel out, 1 over cosine squared x, which would be the same thing as secant squared x. Okay, let's flip it over. And some of these you might recognize. Some of these that are on the back, I kind of introduced these to you in Unit 4B. Just the idea, I kind of introduced it to you of factoring. So this first couple might look familiar, and if they are, that's great. You'll remember them. But I put over here, start by using substitution. It might make it easier. And all that I mean by that is, kind of simplify a little bit. So instead of 2 sine squared, let's make it 2y squared plus y. And then this 1, I'll bring it over as a minus 1 instead of equal to 0, and think factoring. Okay? So we're going to try to factor these guys. So 2y and y. I need the inner product to be a 1, so this needs to be plus 1 minus 1. Now plug your sine x back in. So 2 sine x minus 1. If this product, or the product of these two equals 0, that means each one individually needs to equal 0. You got to account for both. So sine x would equal, if we're bringing the 1 over, be a positive 1, then divided by 2. Here, sine x, I'll put an or, sine x equals negative 1. So I don't have a unit circle on me, and I want you guys to be able to do this without a unit circle. Think, what would make sine x equal 1/2? Think, if I'm just drawing my quick unit circle here, sine represents the y coordinate. So I'm going up a half. I'm going to the right and up a half to a point, or I'm going left and up a half to a point. Now, what kind of triangles would be formed by doing that? Well, if it's a unit circle, the radius is 1, or the hypotenuse is 1. And these are 30, 60, 90 triangles, with this being 30 degrees in here. Now, if we're going to write this in terms of pi, though, one of my answers is 30 degrees, which would be pi over 6. Now, I know also here, so take it one step further and make sure you write all the solutions. So I could put pi over 6 plus 2 pi n as one of my answers, comma. Now this one over here, this is 30 degrees short of half a circle. So that's pi over 6 short of 1 pi. So that'd be 5 pi over 6. I'm going to put 2 pi in just to cover all the possible solutions. Comma, now when does sine equal negative 1? There's only one time that the y coordinate is negative 1. That's when it's down here. So down negative 1, that's 270 degrees, which is 3 pi over 2. And I'll put in the 2 pi in just to cover all the possible solutions. So there's my answers to that one. Same idea here. When you see something like this, sine squared and sine, I think I'm probably going to factor with that. So if it helps you, plug in a y. If you don't need to, that's fine. You don't have to do that y thing. It's up to you. But I'm going to, just for those of you who might help, so y squared minus 2y equals 0. Y times y minus 2 equals 0. Now plug it back in. So sine x times sine x minus 2 equals 0. That means sine x equals 0, or sine x minus 2 equals 0, which means equals 2. Now remember, sine and cosine, the range is from negative 1 to 1. This could never happen, so I'm just going to throw that out. There's no answers coming from that one. Now when does sine equal 0? which means on the coordinate or on the unit circle, when did I go up? None. Well, it's either to the right or to the left. So that'd be at 0 or at 180, which is, I'll say slash. That's a bad one. I'll put a slash this way, pi. It looks like 180 over pi, and we don't want to get messed up there. So we do 180 or pi. Well, let's put it in terms of pi. Now, I could put 0 plus 2 pi, or I could put 2 pi in, or I could put pi plus 2 pi in. But actually, it's here it happens, a pi later it happens, and then a pi later. It happens every pi. So the fastest way to write this would be when x equals pi n, and where n is in those integers. I should put that up here too. Okay, so it's kind of a shorter way to say every pi. So 1 pi, 2 pi, 3 pi, 4 pi versus 0 plus 2 pi and pi plus 2 pi. Well, this hits them all. It's a little bit faster. And this one's a little, maybe a little confusing, but this is more of a leading you into a calculus kind of problem. There are problems like this. They're called derivatives that you have to, at some point, some of them you have to prove, and it's kind of using this idea with trig. So we're going to teach you it now, just so when you get to it, it's not such a shock when you see it next year. So first off, there was a mistake here. This should say 6 sine theta, so change that to a 6. And it says make the suggested trig substitution, so let x equal 6 sine theta, and then use a trig identity to write the resulting function. So first off, radical 36 minus, and this would be 6 sine theta squared. That would be 36 minus, and this, I'm going to square both of those, so it'd be 36 sine squared theta. I got 36 in both, so I don't want to think of this as I'm going to factor out a 36. So 36 and then 1 minus sine squared theta. And then I could do the Pythagorean identity now is 1 minus sine squared is actually cosine squared. So this would be 36 cosine squared theta. And I want to square root both those. Well, you're going to square root them individually. I can do square root of 36 times the square root of cosine squared theta. Because you can put them under one radical or you can separate them. Square root of 36 is, it's going to be plus minus 6, but we want to keep this, with Pythagorean identities, we want to keep this positive. So it's going to be a 6. And then the square root would be cosine theta. And just to keep everything positive, let's do the absolute value of that. So you're always going to just do the absolute value of this when you're on that step. So it'd be 6 times the absolute value of cosine theta. And that makes everything always positive then. Okay? So yeah, let me know if you have any questions on that, and yeah, make sure you get your work done. And I'm assuming there's a lot of snow going on right now. I'm making this over the weekend, assuming that we're going to have a ton of snow in the next few days. But yeah, so let me know if you have questions.